Syzygy, Episode 9. Life on Mars? No, probably not. Welcome back for another episode of Syzygy. This is a pretty exciting one because just in the last week or so, I mean, it really is hot off the presses, this one. There's been a big press announcement from NASA about Mars. And whenever NASA says, hey, journalists, heads up, you might want to pay attention to this one. We're going to be talking about a bit of a discovery on Mars. You know what's coming next. The entire planet goes absolutely berserk with headlines like, has NASA discovered life on Mars? Which would be amazing and incredible if it were true. So, joining me on the microphone to discuss these developments as ever, Dr. Emily Brunston. Hi, Emily.
Hello, hello.
So, has NASA discovered life on Mars?
Nope.
No, they haven't. But, I mean, that doesn't mean that there's nothing going on. So, NASA has announced a couple of really interesting things. So what have they announced? What's going on?
So, well, actually, they've done a really clever thing and they've put two announcements and rolled them up into one.
Okay, so that's always a good way to guarantee a nice big press turnout, is to make the news as big as possible.
Yes,
okay.
yeah.
So what have we got?
And they're actually, well, two announcements come from the same instrument, a NASA rover on Mars. You probably know it more informally as Curiosity.
Curiosity, one of the rovers that just keeps on going.
Yeah.
It's a little buggy about the size of a car, and it was launched in 2011, and it landed on Mars in 2012, because it takes a while to get there. And it landed, and it's been doing its thing, and its mission was 2 years long. And it's still going.
It's going.
It's still going. Just keeps chugging along. I was reading this morning. Do you know how far Curiosity has gone in that period of time? Like, how long is that? That's 6 years now. How far do you think it's gone, actually driven on the surface?
It's a good question. Well, it doesn't go so fast, does it? It's not like,
it's not breaking any land. Well, I was about to say it's not breaking any land speed records. It is for Mars.
Mars speed records.
Yeah.
Yeah. Oh, I'm going to guess 100 kilometers.
Not even close. 18. It's gone a total of 18K.
Okay.
I just love the idea of this little buggy just trundling along, whistling. I like to imagine it whistling to itself. I don't know if it has lips, but...
Well, it sung Happy Birthday to itself a couple of years ago.
Oh, fabulous. We're linking to that. I think that's great. Okay, so back on target then.
Yes.
Curiosity, the little rover that could. What's it found?
Okay, so these two papers were published in Science last week. I'll give you the author credits for each of them because they're obviously two great pieces of work.
Okay.
So the bit where we're going to be talking about the atmosphere and the methane in the atmosphere, that comes from Webster et al., which are part of NASA and part of their JPL, which is the Jet Propulsion Laboratory. And the second paper, which is about the stuff that was found in the ground, in the samples, that comes from Eigenbrod et al., and that comes from NASA's Goddard Space Flight Center.
Right, okay.
Formal.
So that's credit where credit's due. But we've got two different things here, right?
Yes.
Because Curiosity has got all sorts of different instruments on board, and some of them can look downwards and dig into the ground a bit, and we'll get to that in a minute. And then others can kind of look upwards and sample the atmosphere and see what's in there.
Yeah.
And we've got one of each this time around.
Well, it's almost kind of the same instrument, actually, that's doing the measurements, which is really quite cool. And why I think the two papers are also very closely intertwined. In fact, the abstracts of each one mentions the other one.
Right.
Which is really nice.
Well, get the citations going early. That's always good for your H factor, isn't it?
So let's just summarize each one. So the first paper about the atmosphere has found seasonal variations in the amount of methane that's in the atmosphere on Mars.
Okay.
And the other paper, the digging, if you like, paper, is all about finding organic compounds in this particular crater that Curiosity is roaming around in.
Very, very slowly. But it's dug some stuff out of the ground. It's drilled a little way. And when we say a little way, Curiosity doesn't have a bloody great drill on it that it can get meters and hundreds of meters down to the ground. We're talking centimeters here, aren't we?
Yeah, maybe 5 centimeters.
Yeah, it's like you can just dip your finger down into the soil and pull something up. And that's what Curiosity is doing. Which, can I just point out, is not bad for a little buggy which was only supposed to last 2 years and is still going 6 years later and is on another planet. I think it's worth remembering that as well.
Definitely.
Like, well done that it can actually do this at all. So let's start with the methane one, shall we? And I mean, you mentioned the other one, the digging into the soil. They found organic compounds, but methane is also an organic compound.
Yeah.
And let's start there, because this is, I think, one place where people in the media and people around the world getting very excited about these things. You see organic chemistry, organic compounds, organic, but that means life, because anything that we have down here on Earth, which we call organic, whether it's, chicken eggs or organic beans, that's something that's been grown in a particular way, but it's been grown. It's alive. And so organic must mean life, but chemists beg to differ.
Yeah, so chemistry, the branch of organic chemistry is dealing with parts of chemistry that are to do with the carbon molecule and atom. So carbon in its basic form likes to have 4 bonds to things, which makes it really nice for making big long chain structures. You can have organic molecules that have lots of carbon with lots of hydrogen, which is actually the very simplest one of those is methane. You have carbon with 4 hydrogen atoms with it.
So hence the generic term for those, hydrocarbons.
Yeah.
Yeah, carbons with hydrogen and often other little things as well. But these chains or groups of carbon atoms all joined together with bits hanging off them, a lot of which can be hydrogen.
Yeah, and you can stick other things to carbon as well, like OH, which makes it into alcohols and things like that. So the carbon's a very versatile chemical element.
But in the big Venn diagram of chemistry and life, the reason that those two get brought together so much is because we are carbon-based life forms.
We are.
And all life on Earth is carbon-based.
Yep.
So you can have carbon things, you can have organic chemistry that isn't life or that isn't from life, but it could mean life. And so I guess that's kind of where the excitement's coming from, isn't it? If you find some organic chemistry on Mars, then maybe. Okay, so let's pull this apart one bit at a time. Okay. Methane. We found methane, and not only that, but variations in methane over time.
Yeah, so let's think about where Curiosity is at the moment, and basically where it's been for most of its mission.
Yeah, to within 18-kilometre radius, yes.
Indeed. It's been chilling out in this kind of crater. It's called Gale Crater. It was probably used to be a lake at some point in Mars's past, and we'll talk a little bit about the history of Mars, I think, when we examine how life may have once been there, if not there now. And it's this kind of mudstone bottom of the lake. So just like lakes on Earth, this kind of muddy sediment bottom sort of grew over the time as the lake was there. And now Curiosity is running around in this dry lake bed.
Yeah, very much dry. It's not like it's sort of bogged down in the mud. There is no mud, but you can still look at the way the rocks and the sediment are sitting and go, well, hang on, we recognise that. We see that on Earth. We see that in places where there's been water.
Yeah.
And so it's pretty conclusively the bottom of a lake.
Yeah. And because it's been in this one place, basically, for we're coming up 6 years now, we've been able to make measurements of the methane over time, over the Mars year. So the Mars year is just under 2 Earth years.
Right.
So in a Mars, there's been about 3 Mars years since Curiosity's landed. And over those 3 years, they've seen this cyclic variation in the amount of methane that's being picked up just from the background atmosphere.
And how cool is that, by the way, that just extraordinarily long mission time that Curiosity's got, well beyond what it was expected to do, has given it the ability to actually see that variation. Because if it had only been there for 1 Martian year, 2 Earth years, it wouldn't have seen the pattern. It would have seen a bit of variation, but it wouldn't have seen a repetition of that over 3 Mars years. So well done again.
Yeah,
Curiosity.
No, it's really awesome. And it's one of the first times we've seen this from the same spot. So we've seen methane before. We've even detected methane in Mars's atmosphere from Earth. But because we're sitting in one place and just waiting to see what the changes are in one place over time, this is the first time we've been able to say for sure that there's been these seasonal variations. Otherwise, you're sort of sampling maybe from one point at the top of Mars and then from the bottom, and you don't really, it's hard to put those results together.
You haven't got that kind of resolution if you're looking from Earth. But you do if you're a small rover sitting in the bottom of a lake for very long periods of time. So that seasonal variation, I guess the obvious question is, so what? What does that mean?
So methane's a really interesting gas in that it doesn't hang around for very long, especially not in Mars's atmosphere. So it can only last for about a couple of 100 years before it gets destroyed by radiation processes and from the sun. So we know that there must be a source for methane.
Right, something's making it up there.
Yeah.
Okay.
Otherwise we wouldn't see it at all. So now we're seeing that the amount of methane in the background is changing over time. So there's either a biological or a geological process which is linked to the seasons on Mars that's changing the amount of methane that's being produced.
Okay. Is there a strong bet either way on that? I mean, as soon as you say biological, everyone's eyes light up. It's fantastic. There's Martians. Or geological. Is there a best guess at this point?
Well, what I think this discovery has told us more than anything else is that we can rule out some geological processes.
Right.
Not all of them, but just some of them. So we thought maybe that there might be a variation because the amount of UV light, so slightly bluer light than what we can see, coming from the sun, if it hits rocks on Mars, you can sort of ionize off some of the gas. You can change the amount of methane in the atmosphere just from the amount of UV light that the surface is getting. But the change that we saw, or that Curiosity measured, is much, much too big for that to be the process.
Okay, so seems like strike that one out. It's not the UV.
Yeah.
So what are the other possibilities?
Well, we also thought about meteorites coming down and hitting the surface, anything from kind of dust grains, like we get very, very tiny meteors on Earth. The same thing happens on Mars. You get lots of little impacts, or even up to sort of slightly bigger things. If you have an impact, then you could generate some kind of kickback and put some gas back into the atmosphere.
I'd imagine that happens somewhat more frequently on Mars as well, given that it's got a thinner atmosphere. More things would get through.
Probably, to the surface, they definitely would, So impacts maybe, but again, it's just not enough of a variation to what we've seen. So there are some other processes that are linked.
Okay.
So geological process. Let's go down. Let's start with those.
Let's keep that one going, and then we'll keep the really exciting ones for later.
So, it's kind of a bit complicated, and I'm not a geologist, so I didn't read into all the details. But kind of when you get variations in temperature, you can get variations in outgassing of material from beneath the surface of Mars. And we think there might be a temperature variation, or we've definitely measured a temperature variation, despite the fact that actually this crater is pretty much on the equator of Mars. So it kind of gets a similar amount of light all year round, but because of the way that Mars is tilted, you get this kind of temperature variation, and therefore that will follow a methane abundance variation. If you're getting sort of the rocks warm up and they can let through more methane, basically.
Right. And does that seem to fit with the data?
It sort of seems to fit.
Hasn't been ruled out.
Hasn't been ruled out, no.
Right, okay, so that's possible.
Possible.
Sure.
Or you can go down the biology route.
And let's do that. Yeah. Let's go down the biology route because that's where the excitement and potentially funding is. So let's do that.
So, okay, we know that cows, for example, on Earth produce lots of methane.
Yes.
There are definitely not cows on Mars.
Oh, damn. I was going to write that grant proposal as well. I've solved your problem, NASA. It's cows.
Yeah, no, they're not cows. So what the biological candidate, if you like, would be something like a methanogenic bacteria. So that's a bacterium that produces methane. And we got lots of them on Earth. Actually, there's a whole group who study them here at the University of York. And there probably exists quite a lot of them at the bottom of our lake here.
Right, yeah. Okay, so it may be that there is, on Mars, very small bacteria which are churning away, doing chemical reactions, the output of which is methane. And that is varying with the seasons.
Yeah, so there's some sort of life cycle of the bacteria themselves, which is associated with temperature and seasons. And so they produce more and when it's a bit warmer and vice versa. But
very important to point out that this is speculation.
Yes,
right.
Definitely.
There
definitely.
are other explanations exist.
Yeah, if it helps to keep your hopes up, then actually most of the methane in Earth's atmosphere is organic or biological in origin. So maybe that means the same for Mars.
All right. I mean, this is a heck of a lot better than we've seen nothing that points at all in any direction towards life. This is a much more interesting discovery than that. Okay, so there was a second paper. There was the methane paper, and then there was a second paper, which was about rock samples and finding organic compounds in the rocks. Okay, so what's the content of that paper?
Okay, so this is actually using exactly the same instrument, which is quite cool. So what Curiosity does is it picks up a little bit of dust, dirt, whatever you want to call it,
Martian stuff,
off the surface of Mars, and it heats it up until it starts to basically break down, and you get the gases coming off. So it's the same instrument, if you like, recording what's going on, except you're heating up a bit of Mars rock to see what's in it. And they found quite a few really interesting things. I might butcher this pronunciation. I'm not a chemist, but they're called thiophenes, which are types of organic molecules that are linked to sulfur, but they have all this kind of carbon base as well. And then there's kind of other bits and pieces, smaller organic molecules like benzene and propane.
Yeah, I mean, they've found some of the shorter chains, and they've found some of the rings, haven't they? Because benzene is one of these organic molecules that's actually in a little loop of carbon atoms with bits coming off it and stuff like that. So some of the simpler, but not trivially simple, organic molecules.
And there might be that they're just the ones coming off the surface, and actually in the dust itself there's more of the complex long chain molecules. So yeah.
But when you're curiosity and you can really just stick just the tip of your finger down into the soil, that's as good as you can do. That's, it's a start.
Yeah. And I think this is such an important discovery because before we sort of have found some organic compounds, but they were quite different. They had chlorine with them. Now, and that was from a different part of the crater or lake bed, if you like, that was much, much older.
The chemicals that they're finding are in rocks which are billions of years old. So this is not sort of stuff that's been just left behind, organic compounds left behind by something that's crawled across it recently. These are very, very old samples. Yeah,
and we know that organic stuff is not really going to survive on the surface of Mars because you've got all this incoming radiation. The atmosphere just doesn't really protect the surface of the planet like Earth's does.
Yeah, and that's one of the big surprises, really, isn't it? Is you wouldn't expect these things to have lasted as well as they have under the conditions. So is there an explanation for that? Why does NASA think that these things have lasted so long?
Well, part of it might actually be the sulfur. So the sulfur that's with these organic molecules may have acted a little bit like a preserving agent and sort of helped them last as long as they have today. But I guess we need to know a little bit more about those properties. Because we
do that here on Earth, don't we? We put sulfur in. I think I was reading one of the articles that went with this discovery. We put sulfur in things like car tires to make them tougher and last longer. We put sulfur as a preservative in wine? Don't at me. I don't know anything about wine, but that rings a vague bell. So it might be doing a similar sort of thing on Mars, which is kind of cool.
Yeah. So actually the presence of that sulfur might be helping us to see these things, which we maybe didn't really kind of expect to see, or at least not in the quantities that we're seeing at the moment. So that's quite exciting.
So that's cool. Okay. So NASA held a press conference last week, and the world turned its attention to the offices of nasa.org and listened to them say, we found this stuff. We found methane with cyclic variations in the atmosphere. We found organic compounds of various kinds in the soil, in the bottom of this ancient lake bed. And everyone went a little bit nuts in the headlines. But I think actually, looking at it, I don't know what your opinion is. I think the newspapers of the world were actually reasonably restrained. I don't remember seeing any headlines which was, oh my God, life, and they're looking at us and they're going to come invade or anything like that. Like, we didn't have any crazy, well, there was probably a bit, but I didn't see any crazy headlines. I think everyone's been reasonably restrained.
Yeah, I think we're kind of used to the idea that Mars is maybe not the best place in the solar system for life. Actually, we are looking for it, but we're looking really hard just because it's a place that we can get to and we can put these rovers on and so on. So that it's got a chance of having life, maybe more of a chance of used to having life than maybe now. But I think we as humans are kind of familiar with the concept that Mars is a little bit difficult.
It's rough. It's hard work up there. But so what's NASA's angle on this then? They know that they were going to get a lot of coverage for this, and it's a big announcement. But it's not an announcement that says we have found life elsewhere in the universe. So what's their angle?
It's kind of saying don't give up on Mars yet. We're able to rule out some things. We're actually able to rule out some geological processes that we thought were responsible for some of these organic compounds and methane. But we've got upcoming missions that are going to be able to do a bit more than what we can do with our current rovers. So, there's a reason why we're doing that, actually. It's because we've got some, good reasons that there might be something interesting under the surface, particularly. Of Mars.
I mean, one of the NASA people, I can't remember who it was on the NASA website, said we're looking in the right direction. We're going in the right direction. Let's keep this going. And as I said earlier, if the research had come back and said, no, we've got nothing. We've dug down into the soil a couple of centimeters and all we've got is just dust. There's nothing of interest in here. And this isn't saying that. It's saying there is stuff of interest. It's not little microbes. It's not little critters running around. But it is organic stuff that says, keep looking because you might find stuff. So let's talk for a second then about if we do go up to Mars again, there are missions coming in the future which are going to be able to have a closer look, maybe dig a bit further, maybe take samples of different kinds, maybe test them in different ways. Then what sort of things are they going to be looking for? Is NASA expecting or hoping to find life there now, or is it looking for signs of ancient life? What's the best hope? What's the best guess?
That's a really good question, and it's actually pretty similar to an exam question I set my students in planetary sciences. Yeah.
Well, we'll release this after the exam. That's right.
So you can look at life on Mars in kind of two ways. You can either look at it as there was life on Mars in the past, and now it's either dead or pretty much dormant, so we don't see it, or there's life on Mars now, but it's in a very difficult to reach place, like under the ground, very, very deep.
Right. And there is evidence for, if not life in a very long time ago, at least conditions that could have supported it. I mean, as we said before, Curiosity is currently sitting in what we're pretty sure is the bottom of an ancient lake. And we're talking ancient as in millions, if not billions of years old. But there's evidence that there was water. Yes, actual water pooling on the surface of Mars. And if there's one thing that we've learnt about life on Earth is that water works really well.
Yeah, it's basically the one key component we think that life on Earth all needs. So, and we've seen big examples of features on Mars that have been caused by water. So you've got gullies, you've got big channels that have been carved out by some sort of fluid process. So we've got reasonable evidence that water was liquid. But the water can't exist now on the surface of Mars because its atmosphere is not strong enough. It's not high enough pressure.
So what changed? What happened on Mars over such a long period of time? And of course, we are talking extraordinary geological timescales. The Earth 4 billion years ago looked very, very different. But what changed on Mars to mean that there's no water there anymore, or at least there's no water on the surface anymore?
Well, it's probably to do with its size. And every time I remember this kind of little fact, it blows me away. So Mars is only 10% the mass of Earth.
Really?
10%.
Wow.
It's tiny. It's really, really small.
So hang on, if you think about the diameter of Earth and Mars, like looking at them side by side, how big is Mars in comparison to the Earth?
It's a bit smaller, but not 10% smaller. So it's the volume's a bit less.
Right. So why is it so much
It's
lighter?
It's just little. Yeah. It doesn't have quite the lot of heavy iron and rocky core that we do on the Earth.
Right.
At least not to the same extent.
So does that mean that because it's so much less massive, its gravitational field is much weaker? Does that mean that the atmosphere isn't held on as strongly, and
exactly.
just over long periods of time it just dissipates off into the void?
Yeah, so it's only got 40% the gravity we have here on Earth. So you can do some pretty good high jumps on the surface of Mars if you wanted to.
Cool. I mean, that's worth going there alone.
Yeah, it's going to be cool. But yeah, it does mean it can't hold on to a very, very large atmosphere. So if Mars is going to have an atmosphere, it needs to either be producing the gas itself because it can't hold on to it, or it needs to have collected it over some time, and only have light species in its atmosphere. So Mars used to be a geologically active like the Earth, so we used to have sort of volcanoes. I mean, Olympus Mons is very, very famous volcano on Mars, but Mars is much smaller again, which meant it cooled really fast. So just like if you have a shot glass of coffee versus a big mug of coffee, it's going to cool faster. And Mars definitely cooled down and became solid on the inside much, much quicker than we have.
Right. And so much earlier in its planetary history, Mars had the conditions for all sorts of stuff in its atmosphere and all sorts of stuff on its surface, including water, including stuff sloshing about and creating these channels and gullies and all of these wonderful features on the surface of Mars that we recognize as being made by water and flowing stuff. But it lost those properties much faster than Earth has. It's lost its geological activity because it's cooled down. It's lost its atmosphere because it's lost its geological activity and because it's got so much less gravity. And so it's just become a much drier place over time.
Yeah. The original atmosphere that Mars probably had a lot of greenhouse gas in it. And we know from the example like Venus that a lot of greenhouse gas means you can become quite a warm planet, even though Mars is half as distant again as Earth from the sun. So.
Well, we're learning that here on Earth as well, aren't we? But save that for another time.
Yeah, so it probably was able to sustain a temperature which was much, much warmer. So today Mars is only sort of about 200 Kelvin. So what's that, like minus 100 and 100 and something
cold
degrees Celsius. Yeah, sorry, yeah, about 70 degrees. But in the past it probably was about a little bit cooler than Earth is now, but maybe not so different. So liquid water could definitely exist.
So if there is any signs of life on Mars now, whether that's ancient signs of life or indeed life now, it's not sitting in that top dusty layer that Curiosity's been able to get at, but it might be deeper.
Yeah, it could be somewhere deep down under the surface.
Right, and that's somewhere that we're not currently able to go.
No.
With the best will in the world and the greatest of intent, Curiosity is not going to start digging anytime soon, which means that we're going to need to send other stuff up there. So what is in store for the future for Mars?
Well, we've got two really exciting ones that are just on the verge of, coming into completion. So the first one is ExoMars, which is an ESA mission.
Right, so that's the European Space Agency. Have they got something on Mars at the moment, or did they sadly crash?
It's all part of the same mission, actually.
Right.
So ExoMars includes, you might have heard the Trace Gas Orbiter, which TGO, which was launched
I missed that one, but yeah, fill me in.
Okay, it was launched in 2016, got there same year, and from that orbiter, they also sent a lander down. So that might be what you're thinking of.
Could be.
And that was the Schiaparelli lander. Now, unfortunately, it was just a lander, it wasn't really a rover, but unfortunately something went a bit wrong with that lander, and it deployed its parachutes and, crashed into the surface of Mars.
Just bears repeating, landing on another planet is hard.
It's
right?
really hard.
Really hard. We've only done this a couple of times, and it's a long way away. So, I think we can cut them some slack.
Definitely, definitely.
So the Europeans are going back. And tell me a bit about their mission then.
So stage 3, if you like. So they had the orbiter, which is still going, the Trace Gas Orbiter, the lander that crashed, and
pile of rubble on the ground. Yeah.
Fortunately, we can learn from those mistakes.
Yeah.
And stage 3 is a rover. It's quite a cute little rover. I think rovers actually are inherently cute.
I think they are. I mean, it looks a heck of a lot like Wall-E from the film, doesn't it? Yeah. Just zooting around, doing stuff.
And
making friends with cockroaches.
A big part of this rover is to have a drill. So we're going to go beneath the surface, and we're going to go up to 2 meters below the surface.
It doesn't sound like much, but when you compare it to a couple of centimeters, 2 meters is a huge distance.
Yeah. And we don't really know exactly what we're drilling into, right? It's very difficult to design something when you've no idea where you're actually going to be drilling.
I mean, that is absolutely fascinating, isn't it? We know quite a lot about the surface, but still, we've never been into the surface, really, for any distance at all. So could be all sorts of stuff down under there.
Yeah.
It reminds me when they first landed on the moon and when they're climbing down the ladder and just we're pretty sure what we're about to step onto, but we really don't know. We could sink up to our knees in this stuff. We have no idea what it's going to be like. And Mars is, you scratch the surface. What's under there?
Yeah, and we've been caught out by that before. So if you remember the 2 rovers that went up, arrived in Mars in 2004.
That's right. Yeah, what were they called? Spirit and Opportunity.
Opportunity, yes. So Opportunity is amazing. It's still going today.
Yeah. Now, Curiosity lasted longer than its 2-year mission, but Spirit and Opportunity had 1-year missions,
Yeah,
if I remember
something like that,
correctly.
yeah.
And one of them is still going. And that's like 12 years later, 14 years
14
later.
years later.
That's nuts. I mean, well played.
Yeah. Amazing little rover. And even Spirit, so Opportunity is still going. Spirit eventually did power down in about 2010. But, that's still an awful long time. But one thing that flummoxed Spirit a little bit is it got into some sort of sandy bits. Its tyres didn't really go very well. And so we know that the surface of Mars can be a bit variable. So one thing that ExoMars is going to have on it, and I think this is really cool, is it's going to have its own little scout rover.
Oh, so it's a rover with a rover.
It's a rover with a rover. And the scout rover is going to go and prod the ground in front of the main rover.
Brilliant.
To make sure we're not going to get stuck in the sand.
Hey, come this way. Come this way. Don't go over there. Come this way. I think that's lovely.
Cute. Yeah, it's really, really
That's
cute.
really cool. Okay, but more importantly than having cute little sidekicks, they got special new tools and measurement devices and so on to actually get down into the surface and see what's there.
Yeah, so of course we've got better measurement devices, better trace gas element measuring. We got some Raman spectroscopy that's going up. It's all very exciting.
Very exciting. Okay, so that's, you said there were 2 missions.
Yeah.
Okay.
And the other one, which I'm not sure if it's a very good idea to do this, but NASA have the second mission, which is named Mars 2020.
Right. As soon as you put a date on it, you know that's going to become Mars 2021.
Well, it's been a little bit dangerous.
Yeah.
But we'll see. So actually the same year as the ESA mission. And same month, it's a very favourable time to send something to Mars.
Because it's always easier to get to Mars when Mars and Earth are quite close to each other in their orbits, right?
Yes.
Yeah. You don't want to wait until
doesn't happen
Mars is
every
the
day.
other side of the sun. That doesn't.
That's a bad idea. So Mars 2020. Now, talking about cool sidekicks, you want to guess what Mars 2020 is going to have on board?
I read about this. This is fabulous. It's going to have a helicopter.
A drone. It's excellent.
How cool is that?
So for the similar reasons that this little drone's going to fly up only for a few minutes a day, but and look at the surrounding area around the rover and say, oh, that would be a good place to go. Oh, no, we won't go there.
Can you imagine being in the room at NASA and then someone just suddenly going, wait a minute, we could put a drone on it. Oh, yeah, done. Put that in the grant application right now. That's definitely going in. That's brilliant.
Yeah, so for those of you who've been practicing your drone piloting skills, you can work for NASA.
Exactly. There's room for everyone at NASA. Cool. So are both missions basically going to be looking for the same sorts of things? I mean, I'm guessing, not having looked into it, but I'm guessing that the main mission parameters of these two things are, first of all, land safely. Second of all, have a look in the atmosphere and down underground better than we've been able to do before. They will have better instruments. They'll be able to dig further and measure more and take all sorts of different samples and so on. Looking for signs of ancient life or current life. But then I'm guessing also there's a bit of a push towards getting people onto Mars.
Yes, yeah. So while ExoMars is very much focused on trying to find life, it is kind of designed to do that. And we don't know for sure what all the instruments are going to be on either of these spacecraft yet. They're still sort of working out the details. But that's kind of the general focus for ExoMars. Whereas Mars 2020 is a bit broader, and maybe one of the instruments that is proposed to go onto 2020 tells you a little bit more about us thinking about maybe sending some people there. And that's one of the experiments is to see if we can convert carbon dioxide, which there's lots of on Mars, into oxygen. So can we breathe, basically, using some sort of system of converting the CO2 to O2?
I mean, Mars is a pretty hostile place, and not the least of which is that it's an incredibly thin atmosphere that we can't breathe. No. So if we're going to go there, we're going to need something that can do that for us. Yeah, that'd be a useful thing to have.
And we can sort of do that on Earth, but we don't know if we can do that on Mars yet.
Probably better to figure that out before we actually get there.
Yeah, it's usually a good idea. And the other thing is preemptively, I guess, a little bit, this Mars 2020 rover is going to not only collect samples from the surroundings, as it, pull up some bits of rock and things and stash them away, but it will keep them. So we'll hold them on board until one day, maybe, a scientist will come along, find the rover, and pick up the sample.
Oh, right. So it's going to. So I'm guessing that it has an ability, like Curiosity does, to sort of grab some samples and cook them up a bit and see what's inside. But you're talking about analyses which here on Earth take entire labs, take room size or building size facilities in order to be able to do something with, which we just can't do yet. But if we start taking the samples, I mean, as you say, maybe a scientist will get there eventually, or I don't know what the possibilities of getting them back to Earth in a future mission, picking them up and pulling them back again.
Yeah, so that's something we also need to think about. Just can we send a robot that will then go and meet up with this rover, grab all its samples and come bring them back?
So we haven't found life on Mars yet, but it's still all pretty exciting. I mean, NASA is presenting this very much, and the ESA as well, as we've got so much work to do on Mars. Just keep it going. Keep the faith.
Yes, yeah.
Don't give up on Mars.
We might have all these other wonderful exoplanets in the galaxy. We might have all these wonderful places in the solar system that we've been talking about that have prospects for life. Don't let us forget about our own backyard, Mars.
Yeah, let's remember, this one's the easy one. Yeah? Let's get Mars first. Well, that's it for another episode of Syzygy. If you've enjoyed the show, then as we do every week, I'm going to implore you. If you've enjoyed it, then right now, go onto your podcast directory of choice and give us a review, give us a rating, give us some stars, ideally 5 out of 5, and ideally a good review, because that really does help us work our way up through the charts so that other people can discover Syzygy and learn about the fabulous stuff that is going on out there in the universe. If you've got a question or a comment or anything you'd like to throw our way, then you can contact us in various ways. Emily, how can people what's the best way for someone to send us something?
Wow, you got 2 options. You can contact us on Twitter at SyzygyPod, and thanks to the guys from Scunthorpe who did just that after I spoke there last week.
Yeah, shout out to Scunthorpe. I never thought I'd say that, but shout out to Scunthorpe. Well done.
Yep, and you can also jump on our website, syzygy.fm, and there's a little web link there. You can write some comments to us, questions, or anything like that. Send it off and we will see it.
Yeah, if we get some good questions, we may even feature them in a future episode. Speaking of future episodes, look, we haven't worked out what the topic is yet, but the next episode's a big one because it's our number 10. Talk about milestones.
Yeah.
They said it'd never last, and we're approaching episode number 10. So stick around for that one coming up in a week or so. The Syzygy podcast is produced by me, Chris Stewart, with the wonderful help of Dr. Emily Brunston, who has also given up her office just for the occasion. We record here at the University of York pretty much every week, so we're thankful to them for their support. But that's pretty much all we have time for in this week. So until next time, episode 10.
Episode 10.
We'll catch you later.
See you later. If you want to go with methane, you can always go for smelly gas.
Smelly gas? Yeah, we could. Smelly gas on Mars. Could be life. Probably not.
Probably rock farts.
Yep.
I don't like the geese, except I do quite like the black and white ones that hang out by Derwent. They've got little fuzzy white grey chicks. They're really cute. Hi.
I thought you were doing a goose honk there for a second.
Hi.
All this is going to stay in, by the way.
Oh, fabulous.